So welcome to this short presentation on the assessments for Forensic Geoscience, FSC 30013. Okay, so this module has only 2 assessments in response to student feedback from previous years. Assessment 1 is 50% as a student-led group outdoor practical exercise. So you'll be self-enrolling in a group on the VLE. You'll be then going in the field, collecting data, depending on what you want to do, and then you're going to be working up that data and writing a group report. Only one needs to be submitted per group, and then you have a rolling deadline of 3 weeks and 2 days to do that, to submit that, and that's obviously depending on when you do your practical for fairness purposes. The second assessment is also a 50% report, but this is an individual one based on some trace evidence I've already collected for you, and that's deadline for that is week 9. On Wednesday at 1 PM on the VLE deadline. So again, there's more information about that later on. So this first assessment then, it's you've had some experience in the field, maybe the more anthropology perhaps, or other outdoor stuff. If you haven't, don't panic though, but you won't have done much on the geophysics and the geoscience angle, which is what this module's all about. So you're going to give you some basic skills, field skills of the geoforensic world, and hopefully apply some knowledge that you've got in that investigation. So obviously it's group-based, student-led, so you need to decide what to do, and then obviously we'll help you in the field. You're not left to your own devices, don't worry, and hopefully you'll get some good data and process that up, and who knows, maybe some of you will be inspired to actually take this up as a particular topic of interest for you further in your career. So this outdoor practical session, you're going to be getting some practical investigation skills for on-site crime scene investigations in a forensic geoscience world. So we are actually currently collaborating with different police services in the UK with their teams. So we do know what we're doing, and we use this in our actual searches. This is going to be group-based by yourselves though, and led by you. So you'll need to self-enroll into groups of 6 as soon as possible on the VLE. You'll then need to do some sort of planning, deciding who's doing what and when. And then you can actually turn up before the session starts, help move the kit down into the site, collect the data, and then the subsequent practical slots you'll need to be working that data up, and then interrogating where you think things are likely to be buried, and then writing your report. You're going to have 1 practical slot due to the numbers of students we have, and there are a couple of spare slots in the programme in case you've got really bad weather, but be prepared for whatever the weather's likely to be when it's your turn to do it. Okay, so the case background for this study is that the report of an individual acting suspiciously on campus at night. That's obviously me, and witnesses have stated that there's a wide-tracked loaded vehicle, there was a spade, so that the inference is that they've buried something, or more than one thing obviously, because that would be boring, in a specific search area. So we're not sure what that is. It could be arms, it could be people, or something else. We're not sure of the target, but we're relatively sure of the search area. So your preliminary reconnaissance team have been out looking at where this site was, and have actually have dedicated a survey area for you to look at, which has subsequently been roped off for you to investigate. And the area is relatively small, only 5 meters by 14 meters. That should be able to give you some accurate spatial positioning. Some field team have collected some preliminary data, and they're thinking this is an area for you to actually look at and investigate further. So if you need some sort of objectives, you're basically trying to use your forensic geoscience skills to non-invasively investigate a suspect area. So you're not going to be doing any digging, slightly depressingly maybe if you're hoping of doing that, but you'll be using different material, different equipment to try and work out where you want the subsequent intrusive investigation team to do the digging. So that's the same for me if I was doing it commercially or as part of a police search. I would be doing the surveys, and I'm passing on a report for someone else to then start to work out what's causing the anomalies that we're picking up. So you may need to be reading up on some certain skills by lectures that I've given to you, but don't worry, there's short pre-recorded versions already that are on Microsoft Streams that are linked for you in the system. There might be background reading or other materials that you may want to be doing. Remember, you've only got limited time on site. You don't have no idea what you're doing when you turn up, so you do need to think about what you want to do and what techniques you might want to use, and maybe prioritize which ones you want to use first. So think about, there's normally going to be 2 groups on site, so you may decide to decide what they're doing. Maybe there's no point you do both collecting radar data separately, so you may decide to just do it once and share the data later. So you do need to submit some equipment requests to me ahead of time. Obviously not on the morning of the survey, because I can't then configure the equipment or charge up whatever you need. So do a bit of pre-planning here to try and work out what you want to do before you go on site. Of course, risk assessment is really important. So before you even go in the field, you need to have thought about what are the main hazards to try and avoid. That's that's the same for any job you do, not just if you're on a student project. So normally you do that yourself. I've done it for you due to time constraints, especially for the earlier groups. So I've already done that. It's been signed off by the head of school. So do please read that before you go on site. The head of school signed that off as well. So it's on the VLE for you to download and enjoy. Okay, so certain techniques you might want to think about. Some of the basic ones may be surveying, so trying to locate where you're actually sampling. What we're probably going to do is get the technicians to go out and put the survey tapes out of the site before you start. So they'll generally be at a set spacing, such as you can see here in the garden of the Staffordshire University's crime scene house. And you can even just look up for things like lumps and bumps for areas which have previously been disturbed. So that's quite useful. You could go low tech with that, just with the survey tapes, as I mentioned. You could use a total station or take photographs, that side of things. Other things for you, I have collected some LiDAR, ground-based light detection and ranging survey types, which you can pick up and look at sort of some data sets. It's not usually that easy to interpret though, but that's one method that some people use for data collection. Soil surveying is also one option you could do. So you could get some soil probes, probe the ground for surface stiffness. This is an Alistair Ruffell effort. I think it's in his back garden actually, looking for where a cable went through his grassy lawn, and you can see, and just by pushing the machine in, you see which areas are softer, basically where the disturbed ground is. That's quite a useful technique. Other things you will want to be doing is working out what the soil type is. Certain techniques work better in certain soil types. There's some very easy Geography 101 methods of doing this. Again, there's a little notes on this on the VLE in the assessments, and there's also a short lecture on soil types that might be useful to one of your team to view before you go in the field. It's very simple to collect. You can see the guy collecting it in the top right photograph with a soil auger, which is basically a slim sort of probe with a sort of semi-sphere cut out in the middle of that steel to be able to take a sample, and then you can take it out and have a look at it and then try and work out what its type and its colour and things like this, sort of standard soil characterisation. You can be technical and dry the soil and use some sort of automated method to estimate its type, or we'll probably do it in the field using this sort of geography method of trying to work out what the soil type is. So we'll go through this with you when we're in the field. Don't panic. But if you want to have a look at it, there's a PDF of it on the VLE for you. Geophysics is really useful to work out where things are. Geophysics are physical properties of the ground. There's whole lectures on this I'm giving you later in the course, so have a listen to those for some of the main techniques. Certain of them you could use. Magnetics, for example, is very good at detecting ferrous materials, so dominantly metal, not always. Resistivity or conductivity can sort of detect different areas of ground which might have been disturbed or has different materials within it. Quite useful, even where areas have been excavated, for example. That's quite good. And ground penetrating radar, or GPR, is probably the most popularly used to detect isolated objects in the near surface, as in the top 10 meters. So again, there's lectures on that I've given you later in the course, and short versions, so have a read about those. Here's a magnetic example. So the system's quite simple, as you can see by the student holding it there on the left-hand diagram. This is on the right-hand side is a old cemetery in Arkansas, I think, in the States. So the known burials are represented by those grey rectangles, and the subsequent magnetic data collected over the same spot is on the bottom right. So you can see the sort of what high and low magnetic readings, and some of those anomalies correspond to where the graves are, others of them don't. Resistivity, or its inverse, conductivity, measure how either resistant the ground is or how conductive it is, I guess, to some sort of current put into it, with different instruments that do that for you, which you then basically create a series of one-dimensional measurements, and then you contour it up in some software to create a sort of a 2D plan view looking down on the site type methods, such as this example here, looking at a carcass that's been buried again in Staff's Uni's wall garden in their crime scene house. So you often see some sort of coloured results looking like that, and hopefully you'd pick up where things might be, but you don't know what's causing it. It could be anything. So I think there was a linear pipe in the top, sort of going across the top third, and there's a brick on the top right. Seems like really white anomaly as well, so once they found out what it was. Radar's quite nice. It comes with different frequencies for looking for different sized objects. You're collecting again on a line, so effectively a 2D profile has been built up, a vertical slice through the ground, if you like, through that bottom right example. You're not seeing sort of a skull or a body or whatever, you're seeing an object, and that's because it's an EM wave getting pulsed out of that machine, and when you're directly over it, the wave goes up and down. As you go past it or before you get to it, it takes longer for the wave to get there, so you end up with that sort of hyperbolic reflection anomaly, as you can see in that theory image there. But hopefully you can see where the anomalies are on that bottom right example, and anything boring like linear will be sort of background source and take a fee in this example. So for field work, you've got to, there's a lot of groups of you. We haven't got many slots, so we're going to limit it to a one period per group. So decide what you want to do beforehand. There is some virtual familiarisation online on the VLE for you to have a little read about, but remember, you're doing it, not me. So time is short, so try and be proactive, work out what you're going to do first, think about doing some data, maybe have a little meeting about it, and get organised. And once you've got all this data, you then need to work it up. So a lot of the data, other than radar, is sort of XY value formats. So you're going to have some sort of line and distance plots. So you may need to do a little bit of processing, maybe tidying up where there's a dodgy point or something. And then you'll need to put it in some sort of software and contour that data up to produce those plan view maps that I showed you earlier. At Kiel, we've got access to ArcGIS, which is the software that you can use to do that. And again, I've made you a little video guide on how to plot data, so have a look at that link as well when you get time. And as you aren't experts in geophysics, once you've collected your radar data, if that's what you're going to collect, I will process that for you and send you however many separate images of each profile that you collect. It will look at something like this one on the top right, where you've got distance along the profile and two-way time down the side of the profile. And you can see I've arrowed an obvious hyperbolic reflection event, an anomaly, basically in the middle of that plot. And then you can basically convert the position onto the sort of map view of the site. This is line 3, for example, and it's going from the top to the bottom of this plot, on the bottom left of the picture, and then we can work out the distance along that line. So it's about in the middle of the line, isn't it? So that's roughly where the object's located in the survey site. You can also work out its depth by looking at the difference between the top of the hyperbolic reflection event and the ground surface. Work out what that is, and I've just worked this up for you a little bit. So that's about 6 nanoseconds, so that's two-way time, because the wave bounces down and comes back up again. So you can divide that by 2 to make it one-way time, and then you can divide it by the velocity, the average site velocity of the site, to get it to a depth. So that's what those calculations are doing for you. So you can work out it's roughly 30 centimeters down, and where the position is as well. That's why people like radar systems. So hopefully once you've worked up your data a bit, you're going to have some plots to show, some data, some maps, and then your interpretation, so where you think things are. And ideally you'd then have some sort of table with sort of a priority ranked positions, XY positions basically, but relative to maybe a 0 point in the survey grid to show where you think the intrusive investigation team should go next. You can show that various ways. You could hand draw it. You can use the bubble plot option in Excel if you want to do that. It's where you're trying to combine different data types, perhaps to overlay where you think they should be investigated. So you imagine you've got the metal detectors, the radar, and the resistivity all show the same spot. That'll probably be a top priority ranked area. So that could be one method to use it with. I've put an example on the VLE for you to see how you do that. And you need some sort of text to describe that and then why you've chosen the areas that you have. So your report then, it's only one per group. There is a sort of nominal word limit, but I'm more interested in you trying to be concise, having the right areas in there. You've got diagrams, tables, and all that side of things. I have given you quite a detailed guidance of the different how to structure a report and how to put it together, even down to what the different subsections should be, and then some idea of what they should contain as well, because I appreciate you haven't done these before. So again, that's listed for you as I've done here. And as you haven't maybe done an outdoor project before, I have taken the liberty of putting a forensic geophysical survey report on the VLE for you to have a little browse through. So this is we were doing a job a couple of years ago looking for Fred in Cannock Chase, a sort of cold case. Spoiler, didn't find him, but we've gone through the process and you can see how we've structured it and some of that information, so that's useful. You can get the sort of general idea of that. Have a read. There is more advice given to you on the KLE. There's sort of the guidance and marking criteria on the VLE. There's copies of a different report I've put on there for you as well, and obviously your deadline is going to be dependent on when you're doing your practical. Don't forget 10% of the mark is peer review. There's a form to fill in once you've submitted your report, where you sort of grade your colleagues out of 10, and that's part of that finalised mark for yourself. The EC system, as you know, is in place, but if you're obviously I will have to cap it if you submit it after the deadline, or if you haven't submitted an EC. So all my assessments have detailed guidance and marking criteria. So this is just an example, giving you some information. So do please read those and map the guidance and the suggested topic level to your reports. And your marking criteria will give you an idea of what obviously a first class outstanding pass report is and what's everything that's in there. So do please again read that in some detail to look through, and that's obviously going to be some of the feedback you get after it's been marked as well.